Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say welcome to all of you on International Conference of Mechanical, Industrial and Chemical Engineering 2020, especially on the parallel session. Here I am Arif Jumari from Chemical Engineering Department, proudly present the paper with the title of Reductive pretreatment to improve NCA Cathode material hydrometallurgical recycle process. In the last 3 decades, lithium-ion battery has been widely used on many devices of electronic such as laptop, cameras, gadgets, and so on. There are many kinds of lithium-ion battery. One kind of lithium-ion battery is lithium nickel cobalt aluminum. This type of lithium-ion battery has some advantages such as high specific energy densities, high specific power densities, and long life use. Of lithium-ion battery of NCA has significantly increased at least at last 15 years. The increasing of consumption of lithium-ion battery of NCA bring consequences like as the accumulation of spent lithium-ion battery. The last process is hydrometallurgy. Although it gives some disadvantage, but hydrometallurgy gives many advantages, such as it can produce high purity product, it gives high efficiency, it consumes low energy, and gives economical benefit. Especially of lithium-ion battery of NCA, the spent of NCA lithium-ion battery contain lithium, nickel, and cobalt that we know that they are the heavy metals. They can pollute the environment, but they have high economic value, and also they are the limited natural resources. Recovery of metal content of the spent lithium-ion battery, especially on cave of NCA, can be conducted by pyrometallurgy, biometallurgy, or hydrometallurgy. The aim of the research are investigate the various reducing agents on the pretreatment, investigate the effect of organic and inorganic acid on the leaching process, and the last to investigate the leaching time on the leaching efficiency. The recovery metal from spent lithium-ion battery at least contain 2 steps. The steps are pretreatment and leaching. In the first step, the first step is pretreatment. Here, the aluminum sheet will dissolve to the NaOH solution. On the other hand, material of cathode was not solved on the solution. The mixture of the solid liquid was then separated using filtering. Here the reducing agent used were citric acid, oxalic acid, stearic acid, and glucose. The solid mixture was then heated on the furnace at the temperature of 800 Celsius for hours. The mixture of solid was then cleaned, and the product was the spent NCA. The second step was leaching process. The spent NCA obtained from pretreatment process was mixed with leaching solution with a certain concentration. The condition of leaching was 80 Celsius degree with the duration of 1 hour. The ratio of solid and liquid was 20% weight per volume. As I said before, that solid obtained from pretreatment are examined using XRT. From XRT analysis, the result is presented on the figure 1. Here we can see some graph here. Sample with no reducing agent has similar pattern with commercial and GCPDS reference, especially at the 2 theta at 20 degree here, or peak 003. We can see in the graph number 1, number 3 and number 4, we have low peak here. It indicates that the sample has inactive divalent compound nickel oxide. It also indicates that the sample will be easier of the metal leaching. In the leaching process using inorganic acid, we can see that spent NCA with glucose as a reducing agent give the highest result of metal leached in the leaching process. It followed by the NCA with citric acid, NCA with oxalic acid, and the last NCA with citric acid. On the leaching using organic acid, we can see also that the result have similar result here. NCA with glucose as a reducing agent give the highest result of leaching, both Enni and CO. Yeah. From this result also well confirmed with the result of the XRT analysis. Spent NCA with glucose as a reducing agent has the highest nickel and cobalt leaching efficiency compared to the other sample. High leaching efficiency in NCA glucose, NCA stearic acid, NCA citric acid can be attributed to the presence of divalent atom which confirmed by XRT analysis on figure 1. Here NCA leached using organic acid. Here was citric acid, give lower metal leached in comparison with the NCA with hydrogen sulfate here. From here we can say that citric acid solution has lower concentration And increasing citric acid concentration also increase the viscosity of leaching agent with hinder the mass transfer during the leaching process. In the term of efficiency, we can see that the best leaching efficiency using citric acid as a leaching agent was only around 70%. In comparison with the hydrogen sulfate was around 83%. Here showed that hydrogen sulfate more effective as a leaching agent. Okay, we come to the effect of leaching time. Leaching efficiency will increase for all sample both using organic or inorganic acid as the leaching agent. Or in other words, it can be said that the longer the time of leaching, the higher the metal leached on the leaching process. Different concentration between leaching time of 2 and 3 on the leaching process is quite here it can be said that the longer the leaching time, the higher the concentration of metal dissolved in the leaching agent. From exergy analysis, the effect of reducing agent on the structural characteristic of NCA powder was successfully examined, with the result that glucose has the best reducing agent for pretreatment process of spent lithium-ion battery pretreatment. The second conclusion was all the sample leached using citric acid as the leaching agent have low leaching efficiency compared to the leaching using hydrogen sulfate. The higher the metal concentration are dissolved in the leaching agent. This research was funded by LPPM, Lembaga Penelitian dan Pengabdian pada Masyarakat of Universitas 11 Maret through flagship research grant by contract number 452/UN27.21/BN2020. Because of this, I would like to say deep thank to the LPPM of UNS for your attention. Assalamualaikum warahmatullahi wabarakatuh.